multiplication and division are the same thing, but they're just the opposite operations. We're going to use the exact same picture. Okay, so we use the same picture to multiply as we do for division. The difference is when we are setting up the multiplication, we have length times width equals area. So here's my length, here's my width, here's my length times width, and there's my area. So when we rearrange this, we end up with area is equal to the length or width, we'll just call that width, is equal to the area divided by length. So if I want to divide 6x squared by 2x, I need to arrange the 6x squareds so that it has one edge of 2x. And then the answer ends up being the other edge. So here it is written here. So we start with area, we divide by the width, we get the other length. So if I were to show a model for this, so 4x squared divided by 2x, I need to start with areas of 4x squareds. So I have 1x squared, 2x squared, and I need to do it such that one of the edge lengths will be 2. Well, this is easy because I can, either way I do it, I'm going to get an edge length of 2 here. So I'm going to have 2 x's here. Those are my 4x squareds. And this represents this side length and represents the answer. So we can see clear in their picture that the answer is going to be 2x. And again, the same rule applies. It's numbers with numbers and the variables with variables. Okay, that's going to give us those different parts. So in here we can draw this out first, or we can actually work this out. We can work this out as the answer is going to be 2x. 10 divided by 2, x squared divided by x. If we were to draw the picture of this, the area is 10x squareds. And we know that we have 5x along one edge. So we're going to have 5x's along one edge. And I need to be able to fit the 10x squareds in groups of 5. And I can do it in 2 groups of 5. So then the answer then works out to be the other edge here, which is my 2x's. Okay, so this represents, the blue represents the solution to that division statement of those two monomial terms. Now we don't really need to be drawing pictures for all of these, but it is again important that you understand the area, the area model for multiplication and division, because when we start encountering things that we're not familiar with, we need to make sure we go back to these area models and make sure it makes sense with these area models. Now, it's nice to have each individual piece so we can count, back here, if I go back a little bit here. Okay, if I have the 2 times 4, I can see that each piece, I see 8 elements of the x pieces here. But after a while, it kind of gets a little bit redundant to draw every single piece of area. And we want to generalize these areas and use what we call a simplified area model. So instead of showing 3x squared pieces along the one edge, 2x squared, we can just say that we have 3x squared, 2xy cubed. And knowing our rule here, we can say that, well, this area, one piece of area, although there's 6 elements in there, we know because there's 3 times 2, we know this one piece of area is going to have a shape of x cubed, so x squared times x, and y cubed. So there's my variable part. Now if I want to show each individual piece of this, I can do it like this. I can do, a length of x squared, x squared, x squared. There's going to give me my 3x squareds. I can say that I have xy cubed, xy cubed, and I can show my 6 area pieces of x cubed, y cubed like this. Okay, so we can simplify this a little bit and show each individual piece like this. We can see that the 6 boxes here represent the numbers times numbers, 3 times 2. But we want to start being a bit more efficient with what we're doing. So when we do this, we can use our simplified area model. Instead of showing each algebra tile, we're going to just do 3 times 6, x squared times x, and then the y cubed. So the same thing we can say here. We can say that we have 132 xy cubed. There's my area. Remember that this is area. Okay, so I'm just going to write my answer here. This is 6x cubed y cubed. This is my area. Okay, this is going to be I'll make that my width. So 12xy squared. So I know that this other edge length is going to give me my answer to this division statement. So I can just divide numbers with numbers. So that's going to be 11. 132 divided by 12. X divided by x's are going to cancel out. Okay, in fact, I'm going to do it up here. We're going to end up with 11. X's cancel out. And then y cubed divided by y is y squared. It's just 1y. So we're just going to be left with 11y along this edge. Okay, and maybe I'll do that in a different color so we can see where these pieces are coming from. This is going to be 132 divided by 12 is 11. X's cancel. We're left with 1y. So there it is. Here, I'm going to multiply this out. So negative 22 times 3 is negative 66. X squared times x squared gives me x to the power 4. Y cubed times y cubed gives me y to the power 6. Okay, and so this is going to give me a length of negative 22. Negative 22 x squared y cubed. This one piece, so we're just going to group it all together as 3x squared y cubed. And then we get our area is the product. Okay, and again, if we were to show all 22 pieces this way, all 3 pieces horizontally, we can show 66 individual pieces in here. But again, we want to start simplifying things and compressing some of our work so that we can do it more efficiently. And so we can use this simplified area model to give us negative 66. X4, Y6, and we can just represent it as one piece.